We got a lot going on this big old graph, and it says global versus local extrema. Not so mathematical. I don't quite know why I wrote that. But global, okay. We're just putting these in not mathematical terms. Who's the oldest person on the planet versus who's the oldest AP Calc teacher in Ohio? It's not me. Okay. Okay, versus more locally, the oldest AP Calc teacher in Ohio. It's not me, okay? Mr. Richards is not you either if you were teaching AP Calc. So if we're talking local mins and maxes versus absolute, on this closed interval, so this, I did give you a closed interval from A to B, right? And since it's closed, would you say this point is the absolute minimum on this blue graph? Yeah? Okay. Then what do we say? How do we interpret that? What's going on as my function's increasing? What's happening here? It's saying the slope is positive, right? My slope is positive. Then we don't have any extrema here because my slope goes from positive to 0. We've got a horizontal tangent line. Then to what? Yeah, it's just positive again. So my slope didn't change signs. My f prime didn't change signs. Then do you agree that we have a local max over here? It's not the absolute because it's not the highest point. What do we notice about my slope to get that maximum? What happened before that max and after my max? What was my slope before? Positive and after? Okay, so anytime my f prime goes from positive to negative, I'm going to have a maximum. What about over here? My slope went from negative to positive. I'm going to have a minimum. What about my slope at this point? You can't. I like it. Why do you say that? It's a cusp or a corner. We have no slope. But what was my slope doing before? F prime was positive and f prime is negative. We could still have an absolute max there even if I don't have a slope. It's not differentiable at that point. I dig it. Over here, why don't we think we have any extrema over here? My f prime was negative 0 and then continued to be negative. So unless my f prime is changing signs, negative to positive or positive to negative, I won't have any extrema. Local min over here, you down with that? It's the lowest point on that close by, but it's not absolutely the lowest point. So critical points are where that derivative is either 0 or undefined. Just like we were saying in this picture, this is going to be a critical point. This is also going to be a critical point. My derivative is 0. This is a critical point. It's undefined. And what happens at these critical points? These are maybe where we can have maxes or mins. So they're important, even critical, because relative extrema and even absolute extrema can, but don't have to occur at those points. Okay, so let's just label some things over here. Where would my absolute min be on this graph? A. What about my relative max? B. Did I just go in order? Relative min? What's D? D is an absolute max? E? Yeah, because we go lower over other points. I dig it. I could have jumbled that up a little. Sorry. Okay, relative max and min points occur at places where the derivative is or? Exactly. 0 or undefined. Okay, so my local maxes in this picture, local maxes are A and E. My absolute min, B, absolute max. Local min. Really jumbling things up. Do you agree? I don't have a derivative at A or E. I don't have a derivative at D or B because they're corners, but I can have absolute maxes and mins there. Okay, something to note. Relative max and min points occur when, we just said that, is 0 or undefined. Okay. Not all functions have a min or a max. Do you agree with this thing? We've got, and your picture might not have come out well. I apologize about that. What we have over here is a vertical asymptote and then a graph. And this one has no maxes and no mins. Because what's my f prime doing? What's my f prime here, positive or negative? My f prime is negative. What's my f prime here? Negative. It was negative the whole time. It never changed signs, right? What's my f prime here? Positive. Does it ever change signs? Nope. So again, if our f prime isn't changing signs, we don't have maxes and mins. Oh, and this one's all about the interval. The interval is open here, so I don't have a max at B because that point doesn't exist. No max, no min. Close. Oh my gosh. Okay. So extreme values, so a function that is continuous on a closed interval. Closed interval just means that the ends are closed. So if my function was like this, that's a closed interval, then that must have an absolute max and an absolute min. As long as those are filled in, we got maxes and mins. Okay, point for us to note. Critical points are where that derivative is 0 or undefined, and that's where maxes or mins could happen. So it says, hey, where does this function have critical points? So again, a critical point is where the derivative, or f prime, equals 0 or is undefined. Let's go find f prime. What rule do we need to do? Yeah, quotient rule. Let's do it. Low times d high. What's the derivative of the higher? 0. Low d high minus high d low. All over low low. Okay, it says where does my function have critical points? Okay, so we got to see where is this derivative equal to 0 or where is it undefined? If I were to just simplify this a bit, do you agree that's just negative 2x over x squared minus 4 squared? If I just simplified that? Okay, which one do we want to think about first? Let's just go with when does it equal 0. Let's just say when does that equal 0. What would you always do when we've got a fraction equal to 0? Thanks, Harvey. Multiply by that denominator first. And when I multiply by that denominator, they cancel out here, and I'm left with negative 2x equals nothing. Divide by that negative 2, and we get x equals 0. There's one critical point. I'm digging that. Oh, choose all answers that apply. Interesting, because that's just where it equals 0. So I'm down with that. And then we also have to talk about when it's undefined, when a derivative is undefined. Something's going to be undefined when the, yes, bottom equals 0, denominator equals 0. You write whatever helps you. Harvey, you write bottom equals 0 because that's how your brain works. The bottom of the derivative. My derivative one more time was this black function, negative 2x over this x squared minus 4 squared. So for this to be undefined, the denominator, x squared minus 4 squared, would have to be equal to 0. And maybe you let yourself know we're figuring out where it's undefined right now. What would you do first? Yeah, set it equal to 0, and then? Yeah, what was my first step in solving? Oh. Take a square root. What's the square root of 0? Yeah. Add 4. And then square root. And? Minus. Right? Okay. And now, bless you, 2 and negative 2. Whew. Here we go. Where does f have critical points? Here's my function. Critical points, again, is when f prime equals 0 or f prime is undefined. And to Lob's point, we got to do them both. Let's go find f prime first. Whew. Quotient rule again. Low. What's my d high? 1. So I'm not even going to write it because timesing by 1 is just the same. Low d high minus high. D low is 1 again. All over low low. And again, I would simplify this, you guys. Let's simplify that top. On top, are my x's gone now? X minus x. And then would it be negative 2 or negative 4 up top? Wouldn't it be negative 4? Very good, Biscuit. Over x minus 3 squared. That's my f prime, y'all. That's my f prime. We got to do two different scenarios, if you will. We got to set that equal to 0, and we got to set that to see where it's undefined. Guys, when I set that equal to 0, precisely, right? So he's like, okay, I know I got to multiply by that denominator, and when I do, I would get negative 4 equals 0. And he's like, no, it don't. So I don't have a critical point when it's equal to 0.
Do you want us to show that step?
Nope.
Because, like, you just know the setting.
Yep. Yep, you're totally good. And when AP, when they get complicated enough, you'll have to show that stuff because it won't be as obvious. You know what I mean? So for right now, you're great. Perfect. Okay. When does this f prime, which is in black, When is it undefined? That's when the denominator equals 0. So it's undefined when x minus 3 squared equals 0. I bet Bob's going to stop writing that squared, and honestly, that's okay, because every time that first step is going to get rid of it, and I'm good with it. So where is that critical point going to be? At 3. That's it. Okay, critical points, one more time as a reminder, is when my f prime is 0 or my f prime is undefined. Let's go find f prime, y'all. Here's what I do kind of dig about AP is that so many of these rules that we have to memorize, they come back like all the time. So we get a lot of exposure to them as opposed to like having to remember random rules a lot. So let's go find f prime. Derivative of cosine. Close. Very good. Negative sine of x times the derivative of x, which is 1, so we don't have to worry about that. Plus the derivative of 2x, 2. So we got to go see, when does that equal 0? If we got to figure that out, I'm going to go ahead and just add my sine over, if you're okay with that. So I'd say, when does 2 equal the sine of x? Think about that unit circle. Sine starts at 0, goes as high as 1, goes back to 0, then as low as -1. Does sine ever equal 2? No, those sine values are between -1 and 1. So sine never equals 2. Can go as high as 1 and as low as -1. When is this undefined? Yeah, that's exactly right. Why do I want, how do I know that that's is undefined? We're saying never. You're exactly right. Oh yeah, sine is never undefined. Think about it. Sine on the unit circle, the y coordinate always exists, right? It's 0. It's 1/2, root 2 over 2, root 3 over 2, 1. Although it always has a value, it's never undefined. And then you could always add 2 to a value. So that one is toughy, but this one has no critical points. Okay, let's go find where G in this case has critical points. That's where G prime equals 0 or G prime is undefined. Here we go, let's go find G prime. Careful, derivative of sine, cosine times the derivative of that angle. So 3 cosine of 3x. Is that ever going to be equal to 0? Yeah, cosine definitely equals 0 on that unit circle. And so let's just go get rid of that 3 to make our lives a little easier. Okay, this is kind of funky. When does the cosine equal 0? At pi over 2 and negative pi over 2 or 3 pi over 2. Okay, so this quantity, oh, look what they did here. They're saying my answer has to be between 0 and pi over 3. That's in that second quadrant, so they only care about pi over 2. So the cosine of pi over 2 equals 0. So this right here has to read pi over 2. So a way we can think about that is, when does 3x equal pi over 2? Right, this quantity right there has to be a pi over 2 for the cosine to equal 0. So what would I do to solve for that? Divide by 3 is the same as multiply by 1/3. And that helps me see, oh, x would have to be pi over 6. So let me say that one more time, because I think me as a student, I would have struggled with that. If this x was pi over 6 right there, I would have 3 pi over 6, which is really just pi over 2. And that would let me see, oh yeah, the cosine of pi over 2 is 0 there. So we're going to have a critical point at pi over 6. Is the cosine function ever undefined? No, cosine always has values on the unit circle, and then you could always multiply them by 3. So we just have one critical point here. Good. I know there's a little redundant, people, but I just want to make sure that we're feeling okay with it, because we got to build on these critical points. Critical point, again, where f prime equals 0 or f prime is undefined. Let's go find f prime, y'all. 6x squared minus 18x plus 12. Ugh. We got to go figure out where that's equal to 0. That means we'd have to O2 this if we didn't take out a GCF first. Take that GCF out. Agreed. Take that 6 out. Leaving us with, perfect. Then we can just 2. What multiplies by 2 adds to be -3. Yeah. -2, -1, multiply to be positive 2 and add to be negative 3. Agreed. Where does this function, where does this derivative equal 0? At 2 and 1. Do we care about that 6? 6 is never going to equal 0. So we're saying at 2 and 1 it equals 0. So I'm down with 2 and 1. Will a parabola, 6x squared, good little parabola, ever be undefined? Just good old parabola. There aren't any holes. There aren't any vertical asymptotes. Good old parabola is never undefined. So we just have these two. Okay, here we go. To start 5-3, it says, okay, where is a function increasing and decreasing? All right. If my slope is greater than, I don't know really why I had you. If my slope is greater than 0 or my slope is positive, whoosh, if my slope is positive, my function is going to be doing something like this. What would you call that? My function is increasing. That's what they care about. Increasing. And if something has a negative slope, what's it doing? It's decreasing. So my function is, decreasing. I'm just going to say f prime is positive. We've got that right there. F prime is positive. F prime is negative. And AP will take this as an explanation, or you could just say f prime is positive, whichever you prefer. So let's apply that, it says. It says, using the graph below, on what intervals is my function increasing? We know a function is increasing if its slope is positive. Here's a graph of f prime. Here's a graph of f prime. Everything above is positive, everything below is negative. My function would be increasing from where to where?
-6 to -2, and then 2, 4.
Perfect. Here's why I hate these. I feel like it goes against what our eyeballs see. You know what I mean? You're like, wait, this graph is going down. I agree, but this graph is f prime. And this graph's f prime values are 2, and then say 1.5 and 1. These are all positive values here. All of these y values are positive. So when you're looking at a graph of f prime, a function would be increasing anytime that graph is above the x-axis, but AP doesn't want us to say it that way. They want to say because my f prime is positive. My f prime is positive, or you could use words, or f prime is greater than 0. So we're going to say from where to where? You already said it, Ritzy, my bad. -6 to -2, and from 2 to 4, 5. Is that right, guys? And just so you know, if you were to throw parentheses there, they'd be okay with that. I think this is kind of hard to know. Like here, my f prime is actually equal to 0 when it's on that value, but it was decreasing, so they're good with parentheses or brackets at this point. We're also going to say, what's my justification? You only have to say f prime is greater than 0, or f prime is positive. Don't say the word it. What if I said f prime is increasing? They won't take that either, because actually these y values, these f prime values, are actually decreasing, but they're still positive. So don't be using increasing or decreasing. Strictly use these arguments. Okay, let's try this one. Function f is differentiable. Okay. Has exactly 2 zeros. Has exactly 2 zeros. And a 0, again, is where we cross the x-axis, in case you care. Selected values of f prime, the derivative, are shown. Where is f increasing? I know f is increasing when my f prime is greater than 0. I hate this question, actually. I hate it. Where are these f prime values bigger than 0? Yeah, but here's what we got to do. We got to make sure to include, we got to go all the way to this 0 point, because we don't know what happened after it. So we can say, all right, we know that my f primes are positive when x is, we could say,
Bracket for -3 and then parentheses for the 0.
yeah, it's funny. I think I wrote my answer like this was a continuous function, but it's not. So you're saying from -3 all the way to 0. Is that what you're saying?
Yeah.
And actually, but their answer is actually going to have a bracket there, which is annoying because like right here, my f prime value equaled 0. My f prime value equaled 0. So they're going to include it, but you could do a parenthesis if you want. Like I think that this is hard to understand. Also, if we're going to bracket this one, what would we say our other answer is? Where are my F prime values? Say that again? Yeah, exactly. Because those F prime values are positive here, then they're equal to 0. I just think that this is kind of contradictory. Something is increasing when F prime is greater than 0, and we're saying when it equals it. I think that's tough. So they'll accept parentheses or brackets there. My bad. We're saying 4 to 6 here.
It's because,
It says the graph of a function is shown above, for which the following is F prime, not only positive, but also increasing. Okay, we haven't looked at a graph of F yet today. This is just a graph of F. F prime is just its slope. What's the slope of this graph of F at A? Positive or negative? Negative. What's the slope at B? Undefined because it's a cusp per corner. What's my slope at E? Sorry, C. That's letter C. Can't read. Positive. What's the slope at D? Negative. What's the slope at E? Okay, so they're saying when is it positive? We've got 2 points where my slope is positive, but they also want that slope, F prime, to be increasing. My slope at C is positive, but it's approaching 0. So that's actually a decreasing slope because it was positive and then it's going to 0. My slope at E was positive and then it looks like it's getting bigger. So my slope is going to be increasing at E as well as be positive.